All right, Reese, we're sad that you are still not here with us. Today we're doing 526. It's a bigger homework. We are blocked with connections. We will spend class time working on your homework. So we're making one 16 by 4 rectangle. And then two 9 by 9s. Guys, like, this is a skill, like being able to draw and use a ruler and make straight lines. Okay, so quit slowing down your friends who don't have their squares yet. So why did we cross that out? Was it not 16 or what? Okay, well, I mean, make sure we count as we go. This is part. I would mark every 4, right? Because you can go 4, 8, 12, 16. And your 9 by 9s, now this won't work because we need to do a label outside of them. So I would erase this one and draw another square somewhere where you have space. Guys, we're making tables like we've been doing the past couple days. You need space to label on the outsides of them. We need space, like we've been doing. All right, so we have a game to play. But before we get there, we got to review, do probability tables make sense to us at this point? Because yesterday, what did we start creating? It wasn't probability tables, probability trees, right? So we're doing like a quick review. Well, not necessarily quick. We're going to make a couple tables today. We're doing a review of our tables, and then we got a game to play. The game we're playing is similar to yesterday. We're going to spin spinners, but instead of the same spinner twice, please stop, Jackson. Instead of the same spinner twice, we have 2 different spinners to spin and add up. All right, so on your 16 by 4, how we then want to split it up is literally using those 4s. So before we get into this situation, I need a pencil. I don't know where all my pencils went. I've probably loaned those. I've got some in my drawer. I'm okay. I'm confused. I must have given them to kids. All right, so we're going to split this at the 4s to split this up evenly. Because our first situation is going to be an evenly split situation. So here's the prep for the problem. There's our prep for our first problem. So then I want to put the problem in front of you and see if you and your partner can process through how we could create a probability table. Alright, so we all got this on our paper. Anyone here have fish at home? You don't have pet fish? Yeah, how many fish do you have? Actually, ignore that question. What kind of fish do you have? Okay. I used to, well, my fish are at my parents' house now, actually. They have them. Anyone ever go to the pet store and just kind of like watch the fish swim around? Yes. And see all the different colors and stuff? Nope. So, have you ever tried to, at the pet store, Jackson, you might have to help me with this, like get the fish that you're like, ooh, that one's really pretty, I want to get that fish, and you start to use the net to scoop them out, but as soon as the net gets close to them, what do? They go away. Right? They just, so normally at the fish store, pet store, whatever, you can't say like, I want that fish, because it's like almost impossible to catch that specific fish. You can say, I want 3 of those, or I want you to just scoop me up. What? So it's really hard to say I want that specific fish. So at this pet store, they're just going to scoop into the tank. You get what you get, right? It's just, you what? And you don't throw a fit. I've never heard that. I like it. I'm stealing it. Jackson.
When we got our catfish, we actually like 3 of the biggest ones, but it is like with the big ones.
Yeah. All right. So at our pet store, the fish that we have are tetras and guppies. Are the two different types, right? Tetra is a type of fish. Guppy is a type of fish. Each of those types of fish have 4 colors: yellow, orange, blue, and silver. So what I want you to do is try to use that rectangle table. Jackson, can I trust you with a ruler or not? Because you're about to lose it. We're going to use that rectangle table to try to look at like the probability. Like, what's the chance I get a silver tetra? Or a blue guppy? Or an orange tetra? So, like, our 4 colors. Where would we put our 4 colors? Across the top where we have the 4 spots.
With Sophia Scoville, Thomas Lilith, and Caleb Hazlitt, please report to the ferry office for just a moment.
Yellow, orange, blue,
Sophia
silver.
Scoville,
So,
Thomas Lilith, and Caleb Hazlitt to the ferry office for
yellow.
just a moment,
You can abbreviate, right? Orange, blue, silver. And then what would go on the left side of the table? Yeah, the tetra, right? The type of fish, or the guppy. Sure, yeah. Abbreviate.
You've never heard you get what you get, don't throw a fit? You never heard of that? What? Our parents will say this.
Have you ever heard if you saddle up your horse, you can, or if you put the wrong emphasis on the wrong syllable, you can saddle up your horse and go off into the coral?
What? No, it's not 30 years old. Yeah. I haven't heard that. That's a tongue twister.
Listen, if you put the wrong emphasis on the wrong syllable, you can saddle up your horse and go off into the coral.
Are you saying real words?
Here's how it sounds when you say it right. If you put the wrong emphasis on the wrong syllable, you can saddle up your horse and gallop into the corral. But all those words, if you just pronounce them incorrectly, if you put the wrong emphasis on the wrong syllable, you can saddle up your horse and go off into the coral. So, what is our chance? I should get cards.
No one else should.
All right. That's okay, because it was just a little mental break for us while some people were catching up with their drawing. So, Caroline, what is the chance I get a tetra of any color? Half, right? Because tetras are half of my table. Jackson, what's my chance I get a silver tetra?
1/8.
1/8. Why are you saying 1/8?
Because there's not only tetras, there's also guppies, and also silver is one of the 4 colors.
And our silver tetra would be right here, right? Silver tetra, and it's only an 1/8 of the table. And we said there's like equal amounts of these fish, right? There's equal chances. We're just reaching in and scooping out. So, what is our chance of getting a blue fish? I don't care what kind. Blue. We're looking just at blue fish. What's my chance of a blue fish? Yeah, because really, how many of my boxes are the blue fish? 2 out of the how many? 8, right? So 2/8, Phaedra says, really becomes 1/4. Josh, what's my chance at getting a silver or yellow fish? Yeah, either would make me happy. Silver or yellow. Guys, I hope you're listening because this sort of stuff's on your homework. How'd you get 1/2?
So, according to my calculations, if you do, there's tetras and guppies. So, you get 2 for tetra and guppies for silver, and you get 2 for tetra and guppies for yellow. And then that'd be 4/8. But in 4/8, it's just half. So, 1/2.
So, listen up. If you give an or in a probability situation, that means it's going to make things easier. Like, think about the dice, right? What if I want just a 3? Right? chance of getting just a 3? 1 out of 6. But what is my chance of getting a 3 or a 5? 2 out of 6. So or makes things easier because it opens up your options. All right, ready to play a game?
Yes.
We have 2 spinners, but they're mystery spinners, meaning we can't see exactly what they look like. It's always on the wrong screen. I think I have it ready, and it's always on the... So, here's what... Well, actually, it's on your paper. You got 5, 2, 6 in front of you? Who wants to read?
Not me.
Clayton, read this first problem for us.
Wait, 79.
Yeah, it's your team. Sorry, the hole punch. But your team. So right here on our paper, we're reading along with Clayton.
Your team is going to play against your teacher in a game with even spinners. Spinner A has the numbers 2, 3, and 4 on it.
Hold on. Josh, what did he just say?
Spinner A has the numbers 2, 3, and 4 on it.
You might want to, like, I don't know, underline, circle, highlight. Like, that feels important. That spinner A has 2, 3, and 4. Clayton, keep reading.
Spinner B has numbers 6, 7, and 8 on it.
That also feels important. Caroline, what did he just say?
Spinner B has 6, 7, and 8.
You look uninterested is why I called on you. Keep going, Clayton.
The rules are 1. Spin each spinner. 2. Add the results. 3. If the sum is even, one team gets a point. If the sum is odd, the other team gets a point.
So, for example, this round does not matter because you have not chosen even or odd yet,
Underline.
right? Let's say I choose odd because people often tell me that I'm odd. I don't know why. But if I spin spinner 1 and I get 3, spinner 2 I get 7, colors don't matter up here. That's just if we want to do another activity. What did they sum to? And that is even.
Good point.
I lose. Right? Now, that's just one example. I want you and your partner to take the information they told you and make your own decision for your team. You have to decide for your team, and then I'll use random cards to see what your team wants. Do you want to bet on even or odd? And there's no 0 today, right? These are all positive numbers. So we can't get 0, so it's even or odd. Chat with each other. But all we need to know is that you are odd. These are just general meaning class. We're going to what you highlight, the meaning is just the numbers and just the stickers. Now everything highlighted is like full months of cards. All of it. Like, you know what I mean? So when you're highlighting, try to be strategic. What do you guys think? Even or odd? Is it just because that one came up even?
No.
So you got a way to defend why you're saying even? Okay. Okay, Josh, you have no teammates. We might as well hear from you right now. What are you thinking? By the way, Reese, we need you back, so Josh has a teammate. But, like, get healthy, right?
Okay, so I'll pick E.
Josh is saying even. Lakin, what about your team? I defaulted to where you used to sit. And you guys are saying even also? All right, eventually someone's going to have to tell me why. Clayton, what are you guys saying? If you didn't come to a decision, that's like, it's okay. You can say you need my time over. Even just going along with everyone else, just jumping off the bridge with everyone.
I think different. Major one to decide.
Owen, what'd you guys say?
Well, I said odd.
Why? Curious, everyone else said even. I'm curious why you said odd.
So I don't think it really matters because they're all you add all the possible.
I don't know if you're right or wrong, but we can test this, right? Like, I don't know if we're right or wrong, but I bet we could test this using, like, what we've drawn. Because they say spinner 1 can have what results? Or spinner A, what can it be? 2, 3, and 4. Right? What about spinner B?
6, 7, 8.
6, 7, and 8. So just like we did yesterday, I want you guys to fill in this table and see if that changes what you're betting. So we got to add the numbers up to fill this in. Trying to make sure I do not reveal any answers to you guys. If you need help filling it in, you can look up here, but you have a head start on me. You got a head start on me. Oh, okay. Owen would like to change his mind. Why, Owen? So wait, the odds, 9, 11, and 11, right? So Owen's saying the chance of odd, there's 4 out of what? 4 out of 9, right? Because we got 9 results here in our table. And he said the chance of even, 1, 2, 3, 4, 5. Okay, so Owen's saying even is more likely. Would anyone like to bet on odd, or are you guys all taking even? Like, would anyone like to bet on odd? Jackson, you want to bet on odd?
Yes.
You're going to be odd with me? Okay. You'll be odd? Okay. Okay, now we just got a bunch of followers. Alright, so now we're going to start, okay? It's most of you, even, versus us oddballs, okay? Versus us oddballs. You guys chose to... I did not convince you. You chose to join them. Okay, you ready?
Yeah.
We got to add them up and decide like what it is. Alright, I will click them to make sure that you believe that I'm actually spinning them. Alright, spin, spin. 2 and 7. 9, right? So who won?
Me.
Oddballs. If somebody can keep score on their paper if they would like. Hey, Jimmy, go ahead and put that away, please. Next spin. A 3 and an 8. That's odd, right? Oddballs take another one. Next spin. 3, 7. Ooh, even's got one. So now it's like 2 to 1, right? All right, next spin. Next spin. 4 and 7. That's odd. So what's our score now? 3 to 1. All right, next, because 4 plus 7 is 11, right? Yes, that's odd. Yeah. All right, next spin. 2 and 8. Okay, even's got one. Next spin. 3 and 8. Ooh, odd's got it. What's our score now?
4 to 2.
I think it's 4 to 2, right?
I have it down.
Next spin. 2 and 8. Ooh, 4 to 3. Next spin. Hey, how about we do 9 spins, right? Since we were saying out of 9.
Yeah.
You guys said like 4 out of 9, 5 out of 9. Let's do. So how many spins have we done? 7, right? Because we're 4 to 3 right now. So 2 more spins. Spin and spin. Oddballs get that one. And next one. 3 and 8. Oddballs get. Wait a minute. You guys said odd was supposed to win more than even did.
Oh, even.
Liam? Yeah. You guys said even was supposed to win, but odd ended up winning. Liam, what's up? Do we know that even numbers have a higher chance of appearing?
Yes.
We know. We know.
Yeah.
You can see the spin. You know. this is what we assumed. And I think some of you know the little saying, yes, I've heard that one before. What happens when you assume something? So, I'm curious what you assumed. What did you just figure, like, well, everything in this class so far, hey Jackson, put your ruler away. Everything in this class so far, so why would this be different? What did you assume? When you imagined the spinners in your head, what did you think about, like, I can call on people. I was hoping to get some volunteers. But what, Elijah, when you thought about the spinner 2, 3, 4, what did you think it would look like? Did you think it was like 2, 3, and the rest of it 4? Or did you think like a third of it is 2, a third of it is 3, and you thought like it's split up evenly? Caroline, what did you think about the spinners? So when we think about like 6, 7, 8, right? Our 6, 7, 8 spinner. Okay, is that fair? Is that even? Like it, even not the number even, but like split up equally. Okay, so that spinner is fair. Talk with your teammate. See if you want to change your bet. Chat with each other for a minute.
No, it literally has this. Better percentage. Why do you feel like this game is so
Ooh! I was waiting for that word.
Do we even say that?
Clayton, say it louder.
Do we even say this game is rigged?
Well, so when you didn't know the spinners, you made an assumption. Sorry that your assumption was wrong. But now that you can see it, I don't know if we could call it rigged, because like you know what's happening. So sure, is it equal chance? No. But I don't know that we could say it's rigged. Like, how much of the spinner does 3 have here? Jimmy, what are you thinking? How much of the spinner does 3 have there? But give me like good math. Like, how could we talk about like, is it half the spinner or more than that? It's 3/4, right? So this is actually, and guys, this is kind of like the bottom part of your paper here. You can write this stuff on your paper. That's why I gave you that space. That one, Jimmy said, that's 3/4 of our spinner. Or 75%, right? Jackson, what about the 4 up there? How much of the spinner does the 4 get? It's an eighth of it, right? Because this is a quarter together. So here's an eighth, and here's an eighth. How much of this spinner, Liam, is 6? A third of it, right? That's a third. Okay, and then I won't be silly and ask you guys. So I would love it if you would get something looking like this on your paper. Like where I left you circles. Come on, the hard part would be drawing those circles. The hard part would be drawing those circles. So the table that we made. The table that we made. Is that accurate? No. Why? Can anyone tell me why? Like Josh, I heard you say because. Why is the table that we made not accurate?
The table that we made, it assumed that each of them had equal chances to happen.
Yeah, this table gives equal space, equal space, equal space. Do they have equal space? No. So, we're going to draw a new table, And if you need more graph paper, feel free to go get more graph paper. I have tons. We're going to go 16 wide. Here's a trick, though. If you already did 16 wide, you can normally see through your graph paper. And if you can't, you can also line it up and say, okay, if this was 16 wide, if I'm using the same paper, right? The boxes have to be the same size. So you got to check that you line up. But we're going to make another 16 wide. So here I can mark 16 wide by using the one that I already had. So I'm going to go slow to make sure that we all have time. Let's go 16 wide. And let's just do 9 tall.
9 tall.
Yeah, 9 tall. I know it's weird, but it'll make sense in a minute. So 16 wide, 9 tall. 16 wide, 9 tall. 16 by 9. See, we already had 16 from our fish. You don't want to go 16 by 16. You'll see why in a minute. I would beg you to just trust me that I have your best, like I'm on your team.
I'm trusting you, Mr. Hudson. I'm trusting you.
I was not on your team, what? Like, are you still with my metaphor, or do you mean like an actual game?
I'm trusting and
Okay, fine, Josh. When we're competing up at the board, I'm not on your team. I get it. But when I'm teaching, I'm on your team.
I'm trusting.
Also, am I making you give me anything when you lose?
Yes, no.
Well, maybe your pride. Maybe you're giving me your pride.
Give me.
How we doing?
I'm giving you my stage.
Sweet. So now, we're going to split this up. Now wait, so 16, I would have put those checkpoints if I was drawing this manually at every 4. So which spinner was broken up equally?
6, 7, 8.
The 6, 7, 8. So we're going to put 6, 7, 8 over here. I want you and your teammate to decide, how should I put 2, 3, 4 up here? Now wait, I've got this split into fourths right now, right? Like if I 4, 4, 4, and 4, could I split this into eighths? Yeah, I could just do little split there, split there, split there, and split there. So we could split this into eighths. I want you to talk with your teammate about how can we actually model to match what the spinner actually looks like. So we're using rulers so we can actually have straight lines. So I'm going to be in mind that then we're going to use a ruler so we can actually have straight lines to work with. Go ahead and fill in these lines across. When I look at these vertical lines yet, you got to talk about that. Ooh, straight lines, but we have to care about how things look. I'm giving you time.
Yeah, that does look good. So 6, 7, 8 should go on the side. So can you look at your paper again?
Hey, do I need to say that I'm going to collect this for us to care about it? Because if so, I'll collect this at the end of class. All I need is to see that you participated and followed the directions. I'm not asking anything difficult. I just had to start completely over because I gave mine away. So I'm back here at just my empty box. You guys are ahead of me. I don't really want to collect this because I want you to have it for your homework, but I guess I can say I'm going to walk around and check everybody's. So I got this because I had to restart, And we said if we make little tick marks here, we could actually split this into eighths. Do not just do what I'm doing because I'm doing it. But I'm going to draw really light lines so that I can erase them super easy. Do not do this. Like, I mean, you can if you want to, but I'm not telling you you need to. I'm just doing it, well, because I'm teaching you. So I'm going to draw really light lines at each of those, like every 2 boxes. Half of drawing is erasing. I started learning that when I taught a little drawing class. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 sections. Can anyone talk me through what you want me to do to finish my table? Clayton?
So if we go back to like the circle thingies with like about
Yeah, the spinners.
Yeah. So we see 3/4. So if we want to make it to eighths, we would do 6/8. Could you just double it?
Excuse me, so Clayton is saying this 3 has a chance of 3/4. But when we use proportional reasoning, double it, right? Double the 3, double the... So Clayton said this turns into 6/8. Anyone confused by that? So hold on, just one step at a time. So let's do that.
Get the right, we go back to get the right 8, 3, 6.
Sorry, I can't focus while I'm distracted by our classmates. This is just going to eat into homework time. It's a shame because I planned to have like a half hour to do homework, but I'm starting to think that's not going to happen. You good? Yeah, I was distracted by you and Jackson. You guys good now? We need 3 to take up 6/8 of our table. So I drew both of these, like each of these is an eighth, right? Or, honestly, we could have just said 3/4 if you still had your splits at here's 1/4, 2/4, 3/4, right? So my, what number was that? My 3 gets this entire region. It gets this whole section. This whole thing belongs to 3. Yeah.
Throw 8 3 times, 6 times.
Ooh. So Clayton said I could have also done 3, 3, 3, 3, 3, 3.
But who wants to do that?
I mean, but it's fine. You could have. So wait, what would go out here?
4 2.
Ooh, the 2 and the 4. Yes.
Oh yeah.
So like when I was creating this thing, I was like, oh, since 3 is like consuming the entire thing, I just erased all the lines in these areas.
Yeah, I agree.
That's why I was asking, what are you doing?
Okay, so wait, what goes here?
9, 6.
All not.
9, right? Be careful because we've got to add the 3 with. That's a big chunk of 9. But now, Josh, will you? Can I make this line like bold?
Yeah.
That line's safe. And then what about the line between the 2 and the 4? Yeah, I can bold that one. Fill in the rest of that table. I got some more erasing to do. That's why I told you guys not to follow what I was doing. Fill in the rest of that table. grab 2 highlighters? I mean, up to you, but color code even versus odd. I think most of us, you guys have gotten to the point of you have that written down. 10 would go here. 10 goes there. 9. Now you could also just do 1 color of highlighter. What is the probability, like if we try to use a fraction, of this 9? Like, I'm not talking both 9s. If we talk about just this 9. Anyone have a thought? Like, is it a half? No, it's definitely not half the table.
3/4.
You think that 9 is 3/4 of the table?
1/4. What is it?
So hold on. We have a way to figure this out. Jackson, put those in the bin. You're playing. Put them in the bins. When you treat things like toys, you lose them. This 3 had a what chance? I asked you guys to draw the spinners on your paper. 3/4, right? So that 3 had a chance of 3/4. But that was just for the 3. What chance did the 6 have? A third, right? So we said that has a third chance of happening. Do we need the 6 or 3, or do we need the 6 and 3? We need both of them to happen. And here's the tricky part. We're used to and telling us to add. That's not what's happening here. This 9, with the 3 and the 6, how we can figure out the probability of that, we're going to come down to the 12 to show an example, because this 12 is the only 12. So down here, what was the probability of this 4? If we go, an 1/8, right? We said we look at the spinner, that 4 has an 1/8. So that's an 1/8 chance. What's the probability of this 8?
1/3.
A third. So if it's a third of the table, guys, imagine pizza, right? If it's a third of the pizza this way, an 1/8 of the pizza this way. Wait, what if I imagine those lines that I had drawn, right? We had all these lines. Clayton, you got an idea?
Well, for 12 to happen, it'll be 120.
And here's how we don't have to draw all the lines and count all the boxes. Do you know how, like, did you count boxes, or how'd you get there?
Yeah, I counted the boxes, but I just did like 3 times 8.
Guys, we split the table into 3 parts. This is a third. We split the table into 8 parts, which I erased some of, but Clayton just said he did 3 times 8, and that's exactly what we want to do. That's a slim chance, right? To find the probability of 2 things happening at the same time, multiply. So wait, if we know that this box is 1/24, what's this box? 1/24 also. But wait, what about this 11? I could like split, count boxes, or this 11, right? I'm going to color code things. How can I find the probability of that? Well, what am I getting there? I want what numbers to make this 11?
3 times 8.
The 3 and the 8, right? So the probability of 3 and 8. What was the probability of 3? 3/4. What was the probability of 8? Oh, you probably need to take him soon, don't you? Yeah. This was going to be like the last main thing that we did. So 3/4 for our 3. What was the probability for the 8? 1/3. 3. What's 4 times 3? Ooh, 3/12. So this spot on the table is 3/12 for that region. Or if we think in 24ths, it would actually be 6/24. Questions on what we're doing, what we're starting to get a little comfortable with. So a AND situation, you might want to code this on your paper. And with probability tells us that we are going to multiply. With probability, and makes us multiply, because I need two things happening at the same time. So if we think back to our dice, what was the probability of rolling a 12? Well, what's your chance of rolling a 6? 1/6, right? What's your chance of rolling the other 6? So what is 1/6 times 1/6?
24.
Guys, what's 6 times 6? 1 out of 36. Notice that there are 36 total boxes over here, and the 12 is one of them. What's the chance of getting a 2? Well, 1/6 times 1/6, 1 out of 36. Super slim doesn't mean it won't happen, right? But super slim. And I want you guys to take the rest of this time to work on your practice work. So you can pull out Chromebooks to have homework help and answer key up. We got over a half hour left. There is no excuse to not get some stuff done right now. Great. Work on something else. Hey, 525, and I got papers to pass back, but 525 was going to be due tomorrow. I won't see you guys tomorrow. So 525 and 526. Guys, this is your chance to ask a classmate if something's confusing. Ask me. Try homework help, right? Try looking at the answer key, see if it helps.
Yeah, another one. How did I find the configuration event on all this lesson? So, Mr. Munson, that's all your probabilities, guys.
Not a Yeah, you can. Sure, yeah. Hey, so Lakin asked a great question of can he use the graph paper from class as graph paper for the homework assignment? Yeah, sure. You can staple that together. If you're wanting graph paper for your homework, you can use that same page.
Wait, when you say number 9, are you talking about 5 time?
Yes. Because 5 just indicates that we're in chapter 5. We're going to be in chapter 5 for a long time. Well, we've been in chapter 5. We're going to be in chapter 5 for another week-ish. But, it's been a while. Yep, kind of figured as much.
And then I'll take
I would like to help you on number 84. Now, if you choose to ignore me with this, that's a poor choice, but I don't control what you do. I just try to make suggestions. Well, okay, so here, I agree. I realized halfway in that this one wasn't going to be necessary. Here's the problem with this one. 2, 3, and 4 ended up using a denominator of what? We ended up using, like, eighths, right? Like, how many eighths they took up? We had made this 9 squares big. I didn't, like, yeah, we make mistakes, even teachers. I didn't think about, well, 9 can't split into eighths very well, right? So that's why we didn't use this square. But we realized this one was invalid because they didn't actually split things up right. So that's why we had to split differently. And here we kept 9 because we were splitting into thirds, right? So 3, 3, and 3. All right, I want to help you on 84 because this shape on the bottom, anyone know what we call that shape?
A parallelogram.
It is not.
Sorry, a quadrilateral.
But I will tell you this is a parallelogram on bottom. But over here,
Isn't that also a trapezoid right on its side?
so they are different shapes. So it's difficult for me to answer the question you're asking because how you're asking it kind of boxes me in a corner. And apparently you don't care much about the answer since you disengaged. You asked a question, then you disengaged. So I'm just checking what homework help tells you guys, because I always like to know. If you go to homework help for this problem, trapezoids, we have not really dealt with trapezoids yet. So they set up the hint to tell you the formula. If you want to use the actual trapezoid formula, pause what you're doing and look up here. I want you to understand why this is happening. So this base and this base, right? Imagine the trapezoid that's up here. So we're going to call this 5, and we're going to call the top how long? How long is the top in that problem?
Where?
2.5, right? So ignore like my little, like I can turn this way if it helps. Ignore the drawing that I have on here. We're going to call this 5. We're going to call this 2.5, okay? If I want to break this trapezoid, cut it, and reform it like I do with my pizza leftovers, I can take an end off to make it a rectangle. Yeah, I made this. There's magnets in it. So, what happened to my 5 when I take this off? It got shorter. I broke it. I dropped it one day, so I got to glue it at home sometime, but I keep leaving it here because I use it. 5 got shorter, right? My 5 got shorter. But then when I can't just get rid of this, I have to put this on over here. What shape did I just make?
Rectangle.
A rectangle. What happened to my 2.5? Major's not listening. What happened to my 2.5 when I put this shape on?
It added.
It got longer. So here's why the formula is what it is. Elijah's also not listening. Interesting choices made by some of us this morning. The formula is right here on homework help, but it has you add your bases together. That's how it broke last time. So here's what we're going to do. We're going to take your 5 and your 2.5. I would do this on your paper right now. So this area, so I'm just going to put B over here because we're talking about shape B. We add the 5 and the 2.5, but then we divide by 2. Because the 5 got shorter, the 2.5 got longer. So to do that, 5 plus 2.5. Divide by 2. Each of them would now be 3.75. Because I took some of my 5 off, I added it to my other base. So one got bigger, one got smaller. To do that, we average, right? We add the bases together, divide by 2, because one got bigger, one got smaller. But then, if it's a rectangle, how do I find area of a rectangle? Shout it out. Length times width, right? So the 2 dimensions. So we said this is now 3.75. How tall is it? It doesn't change, so it's still 2. So this needs to be times 2 because it's becoming 3.75. So really, we're going to get back to... Now, this does not always happen. It's only because the height is 2. But our answer is actually going to get back to 7.5 centimeters. If it's area, centimeters squared. Bless you. How do we do the area of the top shape? What is the top shape?
A square.
So how do we do the area of that?
2.5.
Yeah, 2.5 times 2.5. So that is actually 6.25. So then to find the total area, what are we going to do? If you have one area for the top, one area for the bottom, how do we find the total? This is the area of the trapezoid. This is the area of the square. Yeah, our total, we're just going to add them. So our total, we're going to add them up. Add them up. All right, you're on your own for the rest of it. Aside from homework help gives you the formulas. So do you like come over to the triangle and you're like, crap, I don't know how to do the triangle. Get on homework help. Also, my answer key shows my work, but really you should get on homework help first and find the formulas there. So I'm still trying to get you guys in the habits of using homework help, using answer keys. Hello. Hold on, I'm going to stop my video.